Now we will begin to explore earthquakes. So before we get into the earthquakes, we need to know about some terminology that's associated with earthquakes. So seismology is the study of earthquakes or seismic waves. So anytime you see this little prefix SEIS, it is referring to something earthquake related. Okay, so ology means study of. So study of earthquakes. Seismology. So when we look down here, we see this SEIS, so we have this size, so we know it's got something to do with earthquakes. Graph. So a seismograph is an instrument that measures earthquakes, so it detects vibrations in the ground. Look, we have it again. SEIS, size, meaning earthquake-related, mogram. Okay, so a seismogram is what you get from a seismograph. So looking at this picture over here, this instrument is the seismograph, and what you get printed out is the seismogram. I'm going to tell you something that you probably already knew. An earthquake is the movement of the ground caused by a sudden release of energy, and this happens when rocks along a fault move. Now, a fault is somewhat new terminology perhaps. It's just a break in the body of rock. So where you have one rock sliding one way, another rock sliding another way, or they could go this, anything of that nature. Just a break in a body of rock. A little science humor for you. Haha. Don't look at me like that. It's not my fault. Ha ha ha. Like the break in a body of rock. Get it? Yeah. Scientists. Crazy people. Alright, getting into the nitty-gritty. How earthquakes happen. So we have rocks on either side of this fault line. So this fault line is just a break in the body of rock. We have rocks on these sides. They're pressed together tightly. Okay, they can, in any direction, they're pressed together tightly. So they will stay immobile until the stress becomes so great that they will just move. Okay, so they will suddenly grind past each other, which will cause vibrations of the ground, such as an earthquake. Alright, after you have the original, here you have your rock on either side. Okay, there's stress here, and once the stress becomes too great, it'll actually move the rocks. Okay, rupture, release of energy, and then the rocks themselves will rebound back to their normal shape. So notice that they're not like curvy like this anymore. So that rebound is called elastic rebound. Now, keep in mind, though, that doesn't necessarily put everything back the way it was just because it rebounds. Like the rocks themselves snap back, not the land the way that it was before. All right, here's some terminology for you. So a focus of an earthquake is going to be inside the Earth's crust, okay? So it's the point where the motion of the earthquake started. It's the origination point of the earthquake inside the crust. Whereas the epicenter is the point on the Earth's surface, which is directly above the focus, so directly above the origination point. And then we have seismic waves, which is the energy released in the form of vibrations when we have an earthquake. So, and look, you have that size, so we know it's earthquake waves. Alright, so here's a picture to show you those three terms. So the focus, this is the point at which the rocks have actually moved. So that's where the earthquake started. The epicenter is the point on the Earth's surface above the focus or above the origination point, but epicenter is on the Earth's surface. Okay, and then here you see we have our seismic waves that radiate out in all directions from the focus. Hey, looks familiar. It's what I just said. They travel out in all directions from the focus. Just like if you threw a rock in a pond and it creates that ripple in all directions. Okay, so there's two types of waves that we're going to learn about. There's body waves and surface waves. Of the two body waves, we have P waves and we have S waves. All right, so a body wave travels through the body of a medium. Okay, so a P wave, those are going to be our primary or compression waves, and we have our S waves, which are our secondary or shear waves, versus our surface waves, which travel along the surface of the Earth. So the ones that we'll focus on are L waves, but there are also Rayleigh waves. Alright, so now using pages 296 and 297 in your Earth Science textbook, there is a Venn diagram here, so you're just going to fill out this Venn diagram comparing and contrasting those three types of waves that we were just talking about. Okay, so if you're going to set it up, let's go ahead and do it together. Let's put our P waves here, our S waves here, and our L waves here. Okay, P and L waves share no similarities, so you shouldn't see anything there. You should have three characteristics under P waves, three characteristics under S waves, and three characteristics under L waves. Okay? There will only be one characteristic that P and S waves share. There's only one that all three of the waves share, and there's only one that S and L share. So now you'll just investigate and fill out this Venn diagram that we'll go over here momentarily.